All right, hey everyone. My name is Nicola. Welcome to another Refdash live session. This one will be on system design, so we'll cover a system design question. We'll do a hands-on system design question. First, I'll set up the structure, then go through the entire problem. Occasionally, I'll stop to hear the comments and figure out the questions together, and then eventually we'll summarize and call it quits at about like hour 15 minutes into this session. At this point, if you feel like some of your friends would love to join and would benefit from this, please feel free to invite them to join. Before we get started, I just want to explain a little bit of the purpose behind these sessions. So as you guys know, at Refdash, we set out to create a different kind of hiring process, the hiring process that is much more friendly for engineers, the one that is less stressful, more objective, and ultimately much faster for engineers. A big part of that, one thing that we noticed by doing thousands of interviews here, is that even people who are doing really well in engineering, often trip up on interview questions because they don't prepare adequately or just sort of like don't pay attention and are not able to articulate their thoughts in an interview setting. So big part of that and what we'll be covering today is system design. That particularly comes in more kind of like senior level positions, and often startups also like to even for junior level positions, they like to sort of typically ask people at least some component of system designs. So just to position this before we get deep into like system design, I just want to position kind of like different types of interviews and just to explain kind of like what exactly we'll be dealing with today, right? So typically, we have some kind of like coding interviews, we have like algorithms interviews, then there is like system design. There is also like object-oriented design, and then some different companies test things on such as like debugging and various other things. What exactly do we mean by system design, right? So that's the least well-defined out of all of these. Typically in coding and algorithms, you get the problem and you go through it with an interview, or you come up with some algorithm and then you implement it. In object-oriented, you're tested for object-oriented patterns and typical things such as like inheritance and other object-oriented concepts. Debugging can be various different things, but system design is very loosely defined as you are asked to implement some very vague open-ended system, right? And you will see that today when the question is literally like 2 sentences and then everything flows from there, right? Nothing is well defined. You're asked to scope out the problem, to sort of like figure out kind of like what are the things that you need to work deeply on, what kind of like analysis to do, how to drive trade-offs and stuff like that. Cool. So today's question will be on this on a system for streaming set of events. So specifically, suppose that you have a streaming set of events and you want to measure some kind of metrics or analytics on this streaming set of events. For example, right? Like what do you want to do? You want to figure out how many events happened in the last X seconds. So that's an example of one metric. So now the question is, how would you design such a metric system? And so just to have you guys follow this closely, I'll share my screen now. And all of you can follow. While I code. You can follow on refdash.com/session. So that's a shared screen that we'll all be able to see, right? Sorry. So I wanted to. Okay, yeah. So this is the problem statement that we'll be dealing with today. So everyone can have this. So if you're just joining, as I said, like you can follow all of this and at refdash.com/session, so that you can get a better screen resolution. But basically, the problem that we'll be dealing with today is to design a metric system for a streaming set of events. As this says, you can assume that you have a streaming set of events and you want to get some analytics or metrics out of it. One example of such a metric would be count the number of events that happened in the last X seconds. So the interviewer would end the question with, how would you approach designing such a system, right? So what do we do here, right? So now I will go back to the board, right? So before we dive deep into this question, I just want to set up a little bit of the expectation of the interview flow, particularly in system design. This applies to general interviews as well, like coding and algorithms, but particularly to system design, it is important to think about three different sections. The first one is kind of like brainstorming. That is the first maybe like 10 to 15 minutes when you come up with a bunch of ideas about kind of like, where can this system go? What is the system built for? All these sorts of ideas about what can you do in the future with a system, right? Then the second section is the section where you typically come up with specific algorithms or different approaches to address how to tackle the challenges and different things that you discovered in the brainstorming section, right? And then finally, the third part is the implementation, right? That is kind of like when you dig into the details, when you figure out, okay, what are the APIs that we need to build for this kind of system? What data structures do we need to use, and so on, right? So that's roughly how we are going to organize this session as well. We are going to first like do some brainstorming, then think about different approaches, and then finally implementing. Across this whole thing, there is analysis, right? So essentially, every decision that you make should be driven by analysis, and you should always be going back to the performance of your system and tying them back to the requirements, right? Like nothing is set in stone. Like your system does not have to be super fast if that's not required. It does not have to consume very little memory if that's not required. But you have to figure out kind of like what you're building for whom and what are the requirements, and then based on that, particularly when you're analyzing different approaches, go back to analysis and figure out what fits, what doesn't fit into your requirements. All right, cool. So now enough with this kind of like introduction. So let's get right into the problem, right? So what are we designing, right? Like we want to design this metric system. Okay, cool. So where does the interview go from here? Very often, one thing that we see in Refdash interviews is that people get, really stuck on these system design interviews because they're like super open-ended and people are used to algorithms and coding. And then, when I sort of like tell them, okay, let's design this event for counting events, very often people will tell you, okay, well, let's just have like one kind of like array where we sort of like add one events as they come in, right? And then when we need to count them, we can sort of like just go back and figure out how many events happened in the last certain period of time, right? That is certainly fine, and that is a very natural thing to think about. It's just that like that's not something that you need that you want to get stuck on, and something that you want to start with. Why? Because before we even started, we don't even know what kind of system we are building for whom, right? Like one thought experiment that I often like to point out to people is that, imagine like when you come into the system design questions, you're talking to an engineer, opposite of you, and you want to have an engineering conversation. And if you came to a company the first day, like you would want to figure out as many questions as possible about the system that you're building. Like what is it for? Kind of like what are the use cases? Who is the user? What are the typical requirements? Okay, so let's go through that flow. In this particular system building, what are we trying to count? Like there is a difference between trying to count entrances into the cinema, for example, and then trying to count the number of queries that go through Google or number of likes that Facebook has. Right? Those are two very different use cases. Why are they different? Well, they're different in the number of events that come in to you every second, every minute, and so on. Right? Another thing that you want to figure out is, what kind of metrics are we talking about? You notice that, like, I've been talking a lot about counts, and very often people get stuck on that. They take this one example thing and they think just about like counts, right? But very careful, if you read the question carefully, I asked about the metric system. So what kind of metrics do we want to figure out? So maybe counts is like certainly like one thing that we talked about, but other things could be like max, min, average. There could be median. All these sorts of different metrics. Like, for example, events can have some metadata, and we might want to ask, okay, what happened in the last, minute in terms of like what was the maximum value of an event, or what was the minimum value, or what was the number of events, average, median. At this point, there should be, like a light bulb in your head in terms of, okay, well, there are sort of like various different metrics, and then I purposely said median because that seems like one that is a little bit more challenging to calculate than these other ones, right? So finally, like, who is the user of this system, right? So maybe after we go through this, maybe like our interviewer tells us, okay, forget about the median, let's think about counts primarily. And then maybe let's leave the possibility for these other things, right? So that's cool. So now the next question is, who is the user of this system, right? Are we building this for people who are on the back end of some server and trying to basically monitor transactions? In which case, we want to figure out kind of like if the servers fail, we maybe want to count the number of errors, count the number of warnings, or different types of things like that. There could be, as I mentioned, this could be for some, merchants, right, where they are trying to count like number of entrances through the door or number of transactions, and maybe they want to charge their customers based on that, right? Like suppose that like someone rents a venue and like you want to count the number of entrances through the door and so on. Another use case could be just like a marketing dashboard where you want to kind of like follow your year over or like month over month, week over week growth, day over day growth, right? Like of for example, Facebook has like number of likes, Google has queries, or various different metrics, right? So all these things are very, very different cases that you need to think about, right? And you want to figure out who exactly you're building this for, right? And so let's pick one, right? Because in this conversation, those would be parts of your brainstorming session. But your interviewer will eventually discuss with you and maybe say, okay, let's say that we are building this for large-scale web systems, and the use case is something like Google Analytics, for example, where you want to have some kind of like dashboard, where you can monitor number of things that happen over time, right? And so this is some time here, right? And you want to monitor that, right? Okay, cool. That seems like a perfectly practical case, right? So now, naturally, after all these questions, it's very clear. Okay, now you kind of clarify the problem, what exactly you're building. Now you want to naturally, like one thing that pops into your mind is like, what are some simple approaches, right? That we can do this. And now we can go back to our approach about like, what if we just kept an array what if we allocated an array that like stores some types of events? Say that like we have some class called event, and every time a new event is recorded, like we just put it here, right? We can certainly do that, right? And then when someone asks us kind of like, okay, how many events happened in the last X seconds, like we can just go from here and then figure out, okay, this is like 7 events, right? Cool. So that certainly seems like a possibility, and like you could potentially just say, okay, problem solved, right? Now, very often in interviews, when we do that, like people stop here and sort of like kind of like pause significantly. As I said, like it's very natural that you kind of like think about this solution, but one thing that kind of distinguishes and makes the interview much better is if you can go beyond that and sort of like critically think and analyze the system. And that is where the analysis comes in. Like every solution that you come up with, you need to tie it back to analysis. So what does this mean in particular here? Well, we need to analyze the performance metrics of our system, right? So what does that specifically mean? That means that we need to analyze the memory, and we need to analyze like time kind of like needed, or latency, or however you want to think about it, right? So in terms of memory, if we are allocating this, it sounds like here in each of these pots, we would need to put one object of some type, and say that we even keep that very minimal. Say that like we have maybe a type of this event, right? Say that we have a type, and say that we have a timestamp, right? And so we can assume that those are like both 4 bytes or something like that. So just to do this kind of like back of the envelope style, I'll just assume 10 bytes, right? Okay, so how many now of these do we have, right? So well, that really depends on how many events we have, right? So let's assume that we have X number of events per second, X per second, and then how many seconds do we have, right? Well, now that really depends on how long in the past we want to store these things, right? Like you wouldn't want to store them for 10 years, but like there is some kind of like Y parameter in terms of like how long you would want to store. Okay, cool. So now we did our basic analysis for memory, right? It seems like in terms of time, it seems like it would take like if you sort of like give me kind of like last X seconds, it seems like it would take, or N seconds, like it seems like it would take order of N time to sort of like go back and look up through this array and sum them up, right? Or sorry, my bad, actually. If you would give me X seconds, again, we would need to understand like how many there are per second, right? So if there are X per second, then this would take, say S is number of seconds times X, right? Like where we would basically need to sort of like go back that many, right? And sort of like sum them up until we reach the point where like timestamp does not, is not adequate anymore. Okay, so that's order of S times X. Okay, cool. So now let's figure out what are X and Y. So those are 2 natural questions that you want to ask next, right? Like what is X? And I see that a good group of people is joining now. So I just want to point out to refdash.com/session. That is where the problem statement is, and that's where I'll be doing some implementation later on, right? Cool. So now naturally the next question is basically kind of like what is this X in terms of what is the what is the number of events that we have per second? So that's naturally a next question that you should ask your interviewer. And at this point of the interview, it really depends on their style, but they might actually flip this question back to you, and they might tell you, okay, well, we have about 1 billion daily users here, right? And so, what do you think that what do you think that the number of events per second are, right? So there you need to do a little bit of the inner analysis as well, and just to think about this, right? Like, some reasonable answer to that could be like, okay, well, there are 1 billion daily active users, right? So that means that, if you sort of like divide that by 24 hours times 3,600 seconds in an hour, this is roughly like 100K, say, or like 86 or whatever, but say 100K, and if there are like billion users, so that's like 10 to the 9, 10 to the 5, so 10 to the 4, right? So that's like 10K users per second. But here you can be, this is like a classic trick that like you want to remember, maybe for like system design, that okay, well, users are not maybe spread out uniformly throughout the day, right? There are some peaks when the users appear, like when the say North America wakes up, right? So you can always like apply some factor of like 10 to multiply, just to sort of like not be off balance. So that's like that's like 10 to the 5 number of users per second, right? And so that's basically 100K users per second. So what does that mean, right? What does that mean for our number of events per second, right? So each user could be emitting, let's say, even to blow this up a little bit, say that like we want to track like a bunch of different events. Say that we are on Facebook and we want to track, okay, all the impressions that we have and all the likes that we do, and all sorts of like different kind of like friends that are active while we are active, and so all sorts of those things. So say that like this number of events is like 1,000 events, right? That we want to track every second for each of these users. That might be a little bit of an overestimate, but let's just go with that, right? So that basically means that there are like roughly like 100 million events per second that we want to track, right? So that's a lot of events per second, right? So that's our X, right? Okay, cool. So what is now our Y? Y is like basically how long do we want to keep these events for, right? So that's basically like the number of seconds that we want to keep these events for. Well, suppose that like we want to keep it at least for a month, maybe for a year, right? So then how do we estimate Y? Y we basically just say, okay, well, how many seconds there are? There are 3,600 times 24 times 30 or 365. Let's say 30, right? Let's say that we want to keep this for a month, right? So this is then 86 times 3, so that's like roughly 300K, and then so this is like roughly 3 million, right? Roughly like 3 million seconds in a month. I hope I'm not too much off. I think my math should be correct. Cool. So now we can go back and estimate our memory, basically. Like, okay, so we said like our Y is 3 million and our X is 100 million, right? So let's just remember that, and then basically go here and just estimate, okay, well, memory is then equal to 10 times, this is 100 million, and this is 30 million, right? So that means that this is, let's see, 3,000, and then 10, and then million times million is like basically, since this is bytes, so this is like petabytes, right? Or sorry, terabytes. Terabytes, but then if you sort of like go down to this, you kind of have like 30 petabytes, right? Or let me just look at my notes very quickly. I have 100 million times 30 million times 10. I have 3 petabytes. Okay, so I might be a little off here. So 3 petabytes. Cool. So you know, that's roughly in that range, right? So what is this? This is basically a memory required for month of data, right? 3 petabytes is the memory required for month of data. That seems like a lot, right? And then for time, we kind of said like in order to do this, like it's basically like s times x, and then x is 100 million events per second, right? So this also seems like a pretty long time to sort of like retrieve the counts. Okay, so what can we do at this point, right? This we can say that like, okay, this kind of makes sense. Okay, cool, 3 petabytes, that's fine. But what do you have to ask yourself at this point? At this point, you have to ask yourself, how critical this system is. Like, are we really willing to allocate 3 petabytes of storage for this kind of like event counter, right? Or is this something just kind of like on the side that like we want to measure? So that's where you come back to those initial questions of like, how critical is this system, right? Like, is this a core system, or is this something just that we want to measure for fun? So at this point, we have a few options, right? Like, we can either say, okay, we'll store this on disk, and then we'll basically figure out how to fetch. It's certainly like a lot of memory, but we'll just distribute it across disk. The trade-off that you're making there is that you are potentially sacrificing the speed, right? So you have to understand kind of like how important is the speed here, right? We could potentially put this all in memory and then split across multiple machines and just say, okay, well, 3 petabytes of data, we are just going to split across, potentially, how much. By the way, how much memory is reasonable to allocate per machine? Say that's like on the order of like, I mean, you can even argue like say 10 gigabytes, right? So in this case, like you would have to have like a lot of machines just to even split this to get to this level. And then even if you were able to kind of like condense this and like reduce the memory down and reduce the number of machines down, the problem, the trade-off that you're making here is when you are trying to query, when you're trying to figure out how many events happen in the last X seconds, you would have to basically go across multiple machines and like do a lot of synchronization, like figure out how to merge them and all of that, right? So you add quite a bit of complexity to your system, right? So what are some other ideas basically that we can implement here, right? So we can now go back to our calculation, right? Like, this 3 petabytes, like, and figure out, do we really need that much, right? Like, what are we assuming here? Here we are assuming that we are storing every single event that occurs here. And clearly, the dominant factor is this like 100 million events, right? If we somehow reduce that 100 million to something much smaller, then this would go down dramatically, right? It would make it down into almost like megabytes range, right? So let's see. So what can we do here, right? So the key idea here is, do we need precision to store these events. In other words, like how important is it to store every single event, right? There you need to ask yourself kind of like, again, what kind of system are you building, right? Like if you're building something that needs to count the transactions and you need to actually, for example, charge people based on that, then you certainly need to be very precise and you need to know exactly every event, when it happened, what it was about, and all of that, right? But if you're trying to figure out just like some sort of like simple kind of like metrics and like draw some nice graphs that show you some trends, either that be on the on the server or for marketing purposes, sales purposes, etc., right? Maybe you don't need to be that precise, right? Maybe you can sort of like just estimate to some degree, and maybe you can also control the degree of precision that you want to give here, right? So what is the key idea, right? The key idea is, well, maybe these, instead of being the events, can be basically buckets based on time, right? So like, what if these were like 1 second buckets, right? So then we would need 1 bucket per second, for example, and there are 100 million events per second. So suddenly, suddenly we reduced our memory requirement by 100 million. Right? So what does that give us? So in order to calculate that, right, like, we would just reduce this by 100 million, right? So this would go down to essentially 3 gigabytes divided by 100. So this would be like 30 megabytes, right? You divide by million, you get to 3 gigabytes. And then you divide by 100, and you get to 30 megabytes. Okay, so that seems much more manageable. That's again for a month of data, but now you're storing the data in buckets, right? What is the trade-off that you're making here? You're making, as I mentioned, a precision trade-off, because now if someone asks you kind of like what happened in the last X milliseconds, you cannot give an exact answer, right? Because you don't know. You lost that information by putting them all in the single second bucket, right? Obviously, you can counter that and say, okay, well, then we can have a millisecond buckets, and then we get millisecond precision, right? Obviously, that increases the memory footprint by a factor of 1,000, but at least now we got a lever to play with and to sort of like trade off. But you can see here, like, we are basically trading off precision for memory, right? And that's a good state to be at, because then you can say, okay, well, how much precision do you need? If you don't need more than a day precision, we can reduce this memory even more significantly, right? So that's a good place to be at, right? Cool. So as I said, those are kind of like the three different approaches that we outlined now. So those are 3 different approaches. As I said, the first one would be kind of like store this on disk. Second one would be multiple servers. And the third idea is buckets, right? We outlined kind of like the different trade-offs that each of these come with. And now we have to ask some key questions, right? The key question is, is precision important to us? Do we need to know every single event, right? Like if we are counting transactions, as I said, we better be right and precise. So that's the first question, right? The second question is, how important is speed to us, right? Because if the speed is not important at all, if we can do this kind of like, in a cron job fashion, then storing something on disk is also manageable, right? So those are all questions that you want to ask at this point to your interviewer, and you sort of like provided the analysis in terms of like different approaches and how they would fare against each other. So say that at this point you discuss with your interviewer, and the problem gets further clarified, and you figure out that okay, again, it's a Google Analytics product for kind of like sales and marketing, and you want to know roughly, the number of events. It's not important that you know exactly what happened, in this particular millisecond. Say that, like, the smallest increment here could be like even a day, or something like a second, and then like you kind of like have this like very low memory, right? It seems like we have some question. It says 3 million, not 30 million. 30 million, so that's for number of seconds. So I won't go into that right now, just to not sort of like derail the conversation with, we can certainly do this again. But yes, that's basically number of seconds in a month. Just to look back into my notes. Yeah, it seems like you're right. It seems like it's more like yeah, it's 30 million seconds in a year. Yes, looking at my notes, this is basically on a year basis, so it's 3 million in a year. You're completely correct. Cool. So as I said, like at this point, like you want to figure out kind of like some of these key questions that allow you to make a trade-off between these different approaches. So say that, like, okay, we decided now to go with this bucketization idea because it seems very plausible to sort of like store everything in memory. It seems like it would be reasonably fast to sort of like look up because it's in memory. We are not doing disks, and also the only thing that we are giving up at least a little bit is precision, right? Okay, cool. So this is our winner, and we continue with that, right? So now we get into the implementation part, right? So what is the most important thing to think about here is basically like here's the point when we are getting into details and when we really kind of like need to be very precise about the things that we are doing, right? So there are two APIs that we really want to implement. The first one is kind of like I'll just write a slightly small, bigger. So there is record event. So that's basically like when our event is coming in, and then there is like something like get count, right? We'll figure out the parameters as we go, right? Those will be important, but say that we figured that out later. So get count, you could have like get minimum. Similarly, just do not forget those other metrics. You can have like get max, all those sorts of things, right? Cool. So now I'll go back into the screen sharing mode, and I'll do some coding in the code editor. For those people who joined slightly later, as I mentioned, you can follow this on refdash.com/session. But you will soon also see this on my shared screen. Okay, cool. Just to okay. So it seems like I'm sharing this properly. Cool. So as I said, I'll do this in Python. Honestly, like sometimes it's easier to do these things in Java because it's slightly more convenient for object-oriented stuff. But say that like we have some counter class, or we might want to even name it slightly more generic. For example, you might want to name it like metric estimator, something like that, right? So we'll have some basic initializer. At this point, like we'll have to have some storage. We'll figure out what that is, and then, as I mentioned, like we'll have two methods. One is record event, and then another one is get count. We are not forgetting about the other methods, but we'll deal with them slightly later, or we'll just mention them because we'll definitely not get to implement the entire system. Okay, so cool. So what happens here? So we left out a few things, right? Like one thing is kind of like, what are the parameters to these APIs, right? How do we design them such that they are generic, extendable, for the future and so on, right? Those are like very important things, like very important things to think about, like when designing APIs. So say that like here like we would have some event coming in, and this could be some class, some separate class event, that maybe has like timestamp, and it has maybe like event type, because we talked about different event types, kind of like it could be like Facebook likes, it could be impressions, it could be different sorts of things, right? So say that like for record event, we are just getting that event, basically event context. Here naturally, like we would want to get kind of like start time. We would want to get end time potentially, right? Like here you want to be a little bit more generic, like even though we've been kind of saying, okay, what happened in the last X seconds? Like you want to allow the possibility for people to ask you what happened in a given time period. So that's kind of like start end time. And then potentially you want to have some context or something of that sort, where I cannot think of like many other parameters right now, but something like event type. So you want to get count of a certain event type, but you can certainly imagine other kind of parameters to this query. So sometimes it's useful to just say that this is kind of like event type context, and then this could be yet another class that where you kind of like put a bunch of different things as you have them, right? So it's type, it could be various different things, right? Cool. So what's next, right? So at this point, you kind of like specified basic structure for the APIs. Now you want to kind of like go deeper. Like what are the data structures that you choose to store these these events or these buckets, and how do you exactly do this, right? This is a very important step, right? This is kind of like where you showcase, where in an interview you showcase your knowledge of like data structures and how they different trade-offs and so on, right? So what are some basic requirements that we want to have here, right? So I want to go back to the board and just sort of like think about, okay, what are the basic requirements for this data structure that we will have, right? Well, the first one is basically like we want to be able to expire events, right? Expire buckets, right? Why is that important? We don't want to be storing things for 10 years, right? We want to figure out sorry, just a second. Am I sharing screen or? So let me see. I think I'm not sharing. I'm not sharing screen anymore, right? Right. Cool. Awesome. So going back to this, like the basic requirements are, we want to be able to expire buckets, right? What else do we want to do? You want to be able to answer a query such as get count relatively quickly, right? So that's one thing. And then you want your writes to be reasonably fast, right? So you want your other record event API to be reasonably fast. So that's kind of like what we should have in mind when designing this data structure, right? So what data structure comes naturally to mind is basically like and this is something that you should definitely discuss with your interview. Don't be afraid to discuss these kind of like brute force things, right? The first data structure that comes to mind is just a simple sort of like array list or something, no matter what data type you choose, some ordered array structure, right? So you can basically have just like your buckets here, And then as you, this could be your first second, second second, third second, fourth second, etc. Right? And so what happens is that like you will just count the number of events, you will put them here. You will count the next number of events, you'll put them here, and so on, right? So how does this go against these three constraints that we want to have? Well, expiring buckets seems a little tricky with just a regular array. Why? Because once you come to say that like you want to keep like first million seconds, just for the sake of argument, and then now comes like million plus 1 second. You want to be able to expire this one, right? But like in order to expire that one, like you need to sort of like either like shift things, or it's not very natural. Like either you're trading off like the insertion where you have to move everything else, or if you're constantly pushing things back, then the oldest elements are at the beginning, and then if you want to expire them, you have to sort of like erase them, shift everything. So it seems very complex, right? So now, in order to fix that, like you might think, okay, well, what is a similar data structure that gives me similar properties, but has like very easy expiration, especially from the ends? Well, it's naturally a linked list, right? So you can think of something like that. Okay, well, I could just like keep adding these elements, and then when I need to expire them, okay, cool, I just get rid of that, and then I just keep adding them at the end. Cool, that's awesome. So expiring buckets seems to work here, right? However, if you want to get the count, like now what happens is that you have to you will get your start and end, and then this will be your start, and this will be your end. And so what will you have to do? You will essentially have to go through all these buckets and sort of like sum them up, right? Seems okay, but like it doesn't seem particularly fast, right? Like it seems like we should be able to go faster than that. In terms of like record event, it seems like that should be fairly quick, because like we are just kind of like summing something up and then adding the whole bucket to the end, right? So this one seems cool, but this one seems a little bit slow, right? So can we at this point you can certainly say, okay, well, this seems like a reasonable approach, and you can go forward with that. And I think that in most interviews, like interviewers would be fine with that, because certainly like you covered a bunch of stuff, and this certainly seems like a reasonable thing to do. However, one thing that would distinguish and make this interview really good is like if you actually dig deeper into this data structure, right? So how do you dig deeper? Well, you can say, okay, well, how can we make get count even better, right? So in order to do that, you have to kind of go back to your array initially and figure out kind of how can we avoid things that were hard to do. Well, expiring buckets was hard, but maybe we don't need to expire them. Maybe we can have a constant array, and maybe we can just have an additional pointer that says, okay, well, this is our current bucket, right? And then we can move this as we go, and then keep or writing the last one. So this would be, in this case, your last one, right? So you would write into this, like say, let's run through like a very simple example. Say that like you started and you have like 1, 1, and then 2, and then like 1 again, and then like 10, 15, 4, 9, 5, 4, right? So you can be like, okay, well, this is the last one where I wrote. Okay, now next second comes in. Okay, this is my current bucket, right? So I need to just override these. So this was 1. Now in this current second I have 9, so I just write this, right? So I lost that last bucket. So that's how an expiration can work. Okay, cool. So we made expiration work. Now, in terms of like record event, again, it's very easy, similar to a linked list. Get count, however, still seems pretty slow, right? Like we basically just managed to come back to the list, come back to the linked list. But now what is really interesting about this is that we can be a little clever here and say that instead of storing the counts, we are actually going to store cumulative counts, right? So how would that look like? Say that again, I'll go just back to this. So say that from the beginning of time we had 1. Then here instead of 2 we would have 3. Here we would have 4. Here we would have 14, and then 29, 33, and sort of you get the point. It's 42, 47, and then 4, 51. Right? So instead of just pure counts in that second, we'll store cumulative counts up to there. And then why is that good? Well, that is good because now when you tell me that you want to count from here to here, you can basically just look up the ends, and you can say, okay, well, the number of events that happened in between is 47 minus 4, and that is 43 events, right? And that seems like order one for get count. So that seems to work as well. Record event is still very simple, and so on. The only complication here is what happens when you're expiring this event now? Well, you have to erase 1, and now say that 9 events happened as before. We're just saying 60, right? And now our pointer shifts here, right? And so you can see now basically we are constantly adding to the number of events that we have. So essentially, we are only storing relative amounts, right? At this point, 60 does not really represent. It represents the number that from the very start, which is okay, but it doesn't represent anything in kind of this array. But more importantly, what this gives us as a problem potentially is that we are growing these integers very quickly. Remember, these small numbers is just used for the sake of easy writing into this array. But remember that we have millions of events per second, right? So this cumulative number will grow very, very quickly. And so why is that a problem? Well, that is a problem if we potentially could have an integer overflow, right? If these are some kind of integers, well, then you have to think about okay, well, wait, when will I overflow, right? So I want to pause here just for a second, right, before we go into this overflow issue. And I just want to point out that, as I said before, if this was a little bit complicated, don't worry too much. Definitely sort of when this is recorded, just go back and pause and think about it yourself. This is certainly not required. You could have stayed at linked list or just a regular list with a pointer and have this be order of n instead of order of 1 operation. But this makes it for much better interview. If you can go deeper, and if you are someone who wants to stop and sort of think about these data structures as you design the system, right? Cool. So let's examine the integer overflow issue, right? So how quickly do we go, right? So how can we estimate this, right? So first of all, what is the maximum value of an integer? That's roughly 2 billion, right? That's kind of the max integer value, right? And how we said that. So that's kind of the and so if we have seconds buckets, right? How many seconds are there in a day? There are as we said, roughly 100K seconds, 86 something thousand seconds, but say roughly 100K seconds, right? Cool. So now we want to be able to figure out how quickly will we actually reach this integer overflow, right? So we want to basically figure that out, right? Well, so these integers basically increase by you know, as we said, like, you know, say that like they increase by since they're cumulative, you know, every second you have another, you know, 1,000 events, right? As we said, like, you know, 1,000 events per user. And so then you basically want to figure out, okay, how quickly will this converge, right? So you have like roughly like 2 billion space, right? And then so you have like 10 to the 5 number of seconds in a day, right? So that means that like you have, you know, roughly 2 times 10 to the 4th, you know, number of days, and then per each day, you have about just to pause for a second. So you will be able to, you will actually overflow. Like if you have, I'm doing something wrong here, just for a second. So so say that like you have like 1 million events per second, right? So then every second you're basically increasing the number of events by 1 million, right? And so how many seconds there are in it? So that's like 10 to the 6th, right? Million events, right? So basically you say that like, you know, this is like million, this is like 2 million, 3 million, so on. So then if you have like that many seconds in a day, you know, 10 to the 5th, that basically means that you know, you will very quickly reach actually this number of overflows. So that means that, you know, periodically you will have to actually reset these counts. And so what does that really mean? Well, that means that you will just have to periodically, you know, take this like first number and just say, okay, well, we'll reset that to 0, right? And then we'll basically, you know, subtract that from all these other numbers. So if this was like in our example, if this was like 3, then we would set this to 0, and then we would, you know, do 1 here, and then 11 and 26 and 30 and so on, right? So at some point you would basically just like reset this so that, you know, this initial number that, you know, you get that to be very large after looping many times, you kind of like reset and you get back to 0, right? Cool, awesome. So you know, disregarding these are sort of like few issues. You know, it sounds like we have found ourselves a good data structure to store all these events. So at this point, you know, we should basically proceed and just sort of like implement this in code. And you know, things to think about here are basically things that you know, we want to still be able to do this across multiple event types, and we want to be able to you know, do this in a relatively generic way, right? So at this point, you know, I trust you all to sort of like just be able to sort of like, you know, write the list and then, you know, have the pointer as an additional variable that basically just moves across this list and basically points to kind of where the current step is, right? But let's basically like specify, you know, a little bit closer, kind of like how these two APIs would look like, right? So as we said, like, you know, the two main APIs are get count, and then there is like record event. So get count basically, as I said, you know, will take, you know, start time, end time, and it will take some event context. And then record event will just take event, right? So what do we have to do in the record event, right? Well, in record event, we basically just have to, say that this is, as we already did, like this is inside some class that is, metric estimator. And here you would have some, local variable that basically stores the, current counter, right? And that is potentially initialized to 0, right? So then in record event, what you want to just say is like you want to look up event timestamp, and you want to basically see if, here you clearly want to have like some timestamp that is basically, current timestamp. And you want to basically be able to see like if your event dot timestamp is larger than your current timestamp plus 1 second, then that means that this event is should be counted in the next one. So at that point, what you want to do is you want to basically use your storage at current index needs to be equal to basically current counter. Your current index needs to move. Your timestamp you need to add like 1 second. I'll just like write this as a pseudocode. Like you need to add 1 second to your current timestamp, and your current counter needs to be equal to 1 now for this new event that you just got. And then when you get the count, you want to basically start time and end time, in some event context. Let's ignore event context for now, but basically at this point, like you want to look at this storage, like you want to first like convert these times into indices, and then basically look up storage, or essentially like you'll get start and then in this index, and you just want to do storage of and storage of start, right? And one thing that I forgot here is that like this should actually be storage of current index. It should be current counter plus storage of current index minus 1, right? Okay. Cool. So that basically sketches out these two APIs, right? So at this point, like we can basically kind of like stop with our implementation and just sort of like call that kind of like done. You don't need to go into much more detail with this, but you do want to sort of like stay to the right level of detail and explain kind of like exactly how your data structure interacts with all these methods and how it makes them optimal. At this point, like what you want to point out, the good thing to know is that you won't be able to in like 45 minutes or an hour implement the entire full-fledged system, but at this point, like you want to circle back and think about how this system, think about generality of the system, how it fares against all these requirements that you had in the beginning, and so on, right? Well, first of all, in order to how general is this system, right? Like here we kind of like assume that we have only one event type, right? Like, but if say that we had like more event types, say that like we had Facebook likes, impressions, Google queries, or whatever event types you want, you could just make this storage into some kind of like a dictionary that basically, instead of just being an array, like it's actually a dictionary of arrays, so that you can look up these arrays by different event types. Other things that you might want to mention at this point is kind of like, okay, then event context would carry those that type of information. So in this step where we convert times into indices, we would actually look up the event context, and in this function just sort of like figure out kind of like exactly the storage that we need to look up. Other things that you want to definitely talk about a little bit if you have time is sort of like generality of your system, and like what if someone wants to use it with different sort of configuration? What if someone does not need a precision of 1 second? Well, certainly like you want to basically allow for that. Maybe that's best allowed in your metric estimator constructor, right? So so here you might want to talk about how your user might be able to specify maybe like precision and longevity. So those seem like two parameters that you might want to have configurable. So basically, that's kind of like, how big are the buckets? So is that like 1 second? Maybe you want even to allow, multiple different buckets. You might want to allow, someone to have like both kind of like 1 second bucket, but also 1 hour buckets, and then how many of them, and so on, depending on, how precision is important to them at different times. Maybe, precision is really important, close to the current time period, but maybe it's less important once you are month apart, right? Similarly with longevity, so you might be able to combine both of these two parameters by allowing basically someone to just give you array structures that they want. So you might want to just have them here like provide a list of array structures that they want for each event type. Right, so that's something that you also want to talk about, maybe. Right, other things that you want to talk about here, and that you might get asked, are things to deal with, concurrency, and how how will happen if this is actually hit with like million events per second and so on. Let's talk a little bit about that, right? So like if this actually is hit million events per second, you definitely have to worry about synchronizing these calls. And so what will happen is that writing to this is like particularly important, because that will have you could basically get into the race condition type of situation where like both threads are trying to write to this. Similarly to this, like if you're increasing the current counter basically, and you want to how can you do that in a synchronous way? The easy answer to that is basically just to lock things and to understand kind of like how basically just like wait until you can acquire the lock and then write. You want to worry a little bit about that there, basically by saying like, okay, if we have like millions, how quickly can we actually write? And so you can again do some back of the envelope calculation if you want to sort of like showcase a little bit of your knowledge about like say that like you have like a few gigahertz computer. That means that like you can write at roughly like say that you have like 1 gigahertz. That means that like you can roughly write at like 2 to the 30 instructions per second. So in order to increment one integer, like you can actually do pretty much like billion increments. So if you have like million events per second, that seems perfectly reasonable, right? Like this means that like you can actually do 1 billion actually 1 billion operations. If you need like just like 1 million increments, that certainly seems very feasible. So then locking mechanism should work, right? So those are just some things that you want to think about. To sort of like summarize this whole approach. As we saw, right, like there are kind of like 3 sections of the system design interview. The first one, very important one, the one that's actually fairly easy to do and fairly logical, that you can do even if you don't have much computer science background. But the one that people often skip and drive straight into implementation. So that's basically brainstorming, right? Like figuring out who you are building this for, who is the user, what are the basic use cases, what are the things that we might want to extend to in the future and stuff like that. This is really where you want to sort of like think big, right? Like think kind of like very wide, very broad, and figure out exactly the parts of the system where you might want to go. This second phase, is kind of like where you design your approaches. Right? This is the phase where you kind of like figure out different approaches, and here it's very very important to sort of like tie all of this back to analysis, and to understand really what each of these approaches brings to you and what does it trade off, right? And so then you can ask further questions, more very, very specific questions about kind of like what exactly is the system that you're building. And then finally, there is like the implementation. That's kind of like where you get into the nitty-gritty details of kind of like what data structures you would use, how many servers you would have. This really now depends on the system that you're designing, but these implementing the APIs, how they would interact with your data structure, what would be their time complexities, how do you optimize that by designing smarter data structures and so on, right? And again, always tie back to analysis. I also want to point out that this by no means we kind of like went through this whole question. You're certainly not expected to check every single checkbox in an interview like this. The one thing that I really want to point out is that ultimately any interview is a conversation with another fellow engineer, and if you sort of like approach it that way, and if you just like think through the problems, nobody will expect you to sort of like just make all the check marks. But you do want to show some creativity, particularly in the brainstorming approach. Show in the brainstorming part. Show ability to do analysis and make right decisions based on that. And then finally also show some knowledge of kind of lower level details and understanding of how different data structures work, what are clean APIs that you can implement, how can you extend this, what different extensions you would do, right? This is certainly not expected from you to mention all these things, but I just wanted to go through some of these things so that you are aware of kind of what are the points where you would get what are the points that you would get asked in an interview, right? I think this basically concludes the session. If you have any questions about sort of either this particular session or about Refdash, definitely write to us at info@refdash.com. I would also encourage you to sort of write to us if you would like us to do some particular topic in the future, or if you have some questions that you would like to cover. We'll likely be releasing some more tools that go along with these sessions that would allow you to sort of vote and vote on different topics and choose different topics for the future. And then always definitely, if you feel ready, definitely come to Refdash and do technical interviews where you will talk with engineers one-on-one and get feedback, be able to sort of understand kind of where you can improve, what you're doing well, and then ultimately also our goal is also to help you find jobs. And sort of we partnered with a number of companies that we can connect you to, where you can fast track and go directly on site to their interviews. So yeah, a lot of stuff, a lot of fun stuff happening. You know, stay tuned. We'll be doing a lot more of these sessions, and definitely, you know, ping us in either comments or you know, subscribe to the channel, or write to us at info@refdash.com if you have any questions. All right, thanks for tuning in.